All right, so in the previous example, we were balancing under acidic conditions. This is the reaction we were using. And under acidic conditions, we were adding water molecules to account for the fact that there were missing oxygens on both sides, and that once we added water, we had to counter the fact that water contains hydrogen by adding free hydrogen, the hydronium ion that we remember from honors chemistry that looks like this, and we were doing it simply by adding free hydrogen, and this is what that looked like at the end. Let's get there. So you can see here that we were adding additional hydrogens to counter the water molecules we added. And this is what we mean by balancing under acidic conditions. Today, we're going to look at balancing under basic conditions, and it's very similar. In fact, there's only one additional step. So let's take an equation here and see what's going on. So let's balance this one under acidic conditions, and we'll start just like we did with acidic conditions by assigning oxidation numbers. So that means that we're going to need to pay attention to some rules. We know that oxygens are always -2. I'll make that smaller so it's more legible. Oxygens are always -2. And since this overall molecule has a charge of -1, this nitrogen will have a charge of +3. This aluminum is an elemental, so it has a charge of 0. This is a molecule of ammonia. Hydrogen is always +1, and there are 3 of them, so this nitrogen will have a charge of -3. And finally, here is an ion where the oxygens have a charge of -2, and since it has an overall charge of -1, we'll make this aluminum +3. So we've assigned our oxidation numbers. The next step is going to be our half reactions. And so what we want to do in a half reaction is identify any element that has changed its oxidation number. And of course we know that the nitrogen has gone from +3 to -3, and we know that the aluminum has gone from 0 to +3. So let's get our half reactions. And here is what this is going to look like. We're going to start with our nitrogen. And so here is nitrogen NO2 with a charge of -1, and the nitrogen has a charge of +3. On the reactant side, on the product side, we have NH3, and the nitrogen has a charge of -3. So how did it get from +3 to -3? We've added 6 electrons. Okay, that takes care of the charge. Now let's take care of the fact that there are 2 oxygens over here. And we're going to do that with molecules of water. We'll add 2 molecules of water to take care of the fact that there are 2 oxygens. Now because we have added 2 molecules of water, that means we've added 4 atoms of hydrogen, and so we're going to counter the fact that we've added 4 by adding 4 on this side. And let's make some room here. I'm going to scoot this over. So I would normally, to counter the fact that we've just added 4 atoms of hydrogen, I would add 4 atoms of hydrogen over here. Unfortunately, we also have to take into consideration that there are 3 additional hydrogens on this particular molecule of ammonia. So I'm going to add 7. Okay, let's pause for a second. This is where the difference in basic and acidic conditions applies. Because under basic conditions, we can't just leave hydrogen lying around by itself. And so I'm going to counter the fact that I just added 7 H pluses by also adding 7 hydroxides. That's the difference. These 7 hydroxides are what make this under basic conditions. And because we added 7 hydroxides to this side, we're going to add 7 hydroxides to this side. And that's all that distinguishes basic conditions from acidic. And we're going to come back to these because you're probably looking at this, having just done some neutralization reactions and looking at that going, doesn't that make water? Yes, it does, but we'll come back to that. Let's do our other half reaction involving aluminum. So we have solid aluminum with a charge of 0. And on the product side, we have aluminum in an ion where it now has a charge of +3. Well, how did it get to have a charge of +3? It has to have lost 3 electrons. And that takes care of the charge. What we're going to do now is we're going to compensate for the fact that we have 2 oxygens on that side by adding 2 molecules of water to this side. But because we just added 4 hydrogens to this side, we're going to add 4 hydrogens to this side. And because we are under basic conditions, if we add 4 hydrogens, we have to counter with 4 hydroxides. And if we add 4 hydroxides to that side, we have to add 4 hydroxides to this side. Now this is where things start to get complicated, because we have 6 electrons here and only 3 here. So what we want to do is compensate for charge. We're going to do that by multiplying this entire equation by 2. So let's do that. That gives this 4H2O, 2 aluminums, 8 hydroxides, 2 aluminum oxide molecules, 6 electrons, so now our charges are in line, 8 H pluses, and 8 hydroxides. Whew. Starting to get kind of complicated. So now we're going to take these 2 reactions and we're going to combine them into 2. And let's draw a big line through this one so we don't let that confuse us. Alright, so when we combine both of these equations, what we're going to do is we're going to try to make things easier on ourselves by combining things where we can. So on the reactant side, 7 hydroxides, 7 H pluses, and O2, 6 electrons. That's this side right here. Now we're going to add these. Here are 4 H2O, 2 aluminum, and 8 OH minus. That's just the reactant side. On the product side, we have an H3, 2 H2O, 7 hydroxides, 2 aluminum oxide molecules, 6 electrons, 8 H pluses, and 8 OH minuses. Starting to get a little complicated. So the first thing we're going to do is get rid of stuff that appears on both sides. That takes care of our electrons. Anytime we see a hydroxide next to an H plus, we can combine that to make water. So let's do that. Let's get rid of these guys. This is now 7 molecules of water here, And this is now 8 molecules of water here. And even further, we can combine these 7 with these 4. So now we have 11 molecules of water on this side. And to make things even a bit more simple, because we have 11 molecules of water here and 8 here, these cancel these out and leave us with 3. Okay, those 3 molecules of water, oops, we missed this one. And that means that there is 1 molecule of water left on this side. Here are 8 hydroxides and 7, and that's going to leave 1. And this should take care of it. So let's put these 2 together and see what we get, and then we'll see if it balances. So our final equation, NO2 plus H2O plus 2Al plus OH minus. And on our product side, NH3 and 2AlO2. Let's see what we get. Do these balance? 1 nitrogen. 1 nitrogen. 2 hydrogens plus a third. 3 hydrogens. 2 aluminums. 2 aluminums. 2 oxygens plus another 2 is 4. 4. Here then is our balanced equation. NO2 plus H2O plus 2Al plus OH minus yields NH3 and 2AlO2. You know you did this right under basic conditions if you have some additional hydroxide left over in solution. Okay.